Okay, we're going to look at factorizing. So we're going to start off with just kind of an introduction as to what factorizing and factors are, and then we're going to look at highest common factor, one of the types of factorizing. Then we'll do another video then for some of the other ones. So looking first of all at what a factor is. So we've met this before. This isn't really something new to us. We did this last year. In first year, you would have met in primary school the idea of a factor. So a factor is a number which divides in evenly with no remainder. So like the factors of 24 there are like 1, 2, 3, 4, 6, 8, 12, 24, so on and so forth. So the factors are numbers that divide in evenly. So all of those numbers divide in evenly to 24. And we often think of our factors as coming in pairs. So 1 and 24 would be a factor pair because 1 multiplied by 24 gets me back to 24. Same with 2 and 12. 2 multiplied by 12 gets me back to 24. And each of those divides in evenly to 24 also. In terms of algebra, then a factor may be a term. So we could have something like 2x being a factor, or we could have an expression. So something like 3x plus 4 might be a factor, and that just means it divides in evenly. So something like this might require us to do some long division if we want to divide in evenly. And what we've said also is that these factors come in pairs. So we're expecting that when we have a term, we might have an expression that goes with it, or vice versa. So here I've said the idea of factorizing and the verb of factorizing. And factorizing means it's the opposite of expanding. Okay, so expanding we would have met in the first algebra chapter, and you would have met it last year as well. Expanding or multiplying out is when we take a bracket, say like this one, 3 multiplied by 2x minus 7, and we multiply that out. So we do 3 multiplied by the 2x and 3 multiplied by the minus 7 to give us our 6x minus 21. So we're kind of removing the brackets. When we're factorizing, we're going the opposite direction. So we're taking an expression and we're trying to write it in terms of its factors as a product of those factors. So like here, 6x minus 21 can be rewritten as 3 multiplied by 2x minus 7, where the two factors here are the 3 and the 2x minus 7. Okay, it's okay that it's an algebraic expression. That's kind of what we're leading up to, I suppose. So we're going to look at 4 different types of factorizing in this chapter, and that's what we've kind of been doing in class. So highest common factor is the first one, grouping is the second one, difference of two squares, and then quadratics is the fourth type of factorizing we're going to do. So we're going to look first of all at highest common factor in this video, and we'll do kind of additional videos for the other one. We're just going to quickly go through them all, and we have loads of examples and stuff in our notes as well that we can follow along with. But just looking generally then, and just to set us up for this idea of highest common factor, we're going to look at some quick division. And we did a lot of this when we looked at algebraic division, and that's in the video that I have up for algebraic division as well. We have some of this at the start. So just to revise quickly over that for yourself, x squared divided by x leaves me with just an x. X cubed divided by x squared again leaves me with x. We said here what we were doing was subtracting the powers. So 2 minus 1 gives me this power of 1. 3 minus 2 gives me this power of 1. If I look here, 8x divided by x, that's just going to give me 8. Okay, that's just going to give me 8. And then for the last one, 9x to the power of 4 divided by 3x squared. Well, 9 divided by 3 gives me 3. X to the power of 4 divided by x squared gives me x squared, x to the power of 2. And that's just, again, subtracting the powers. And what we would say there, I suppose, for, say, the third one here, is that 8 is a factor of 8x because it divides in evenly. And also, x is a factor because x divides in evenly. And x and 8 are a factor pair because they're kind of the opposite side of each of those factors. So if I divide by x, I'm left with 8. If I divide by 8, I'm left with x. And if I multiply the two of those, I end up with my original expression. So if I multiply the two factors, it brings me back to where I started with. So that's what we're going to be looking at when we look at highest common factor. Now we know for numbers, the highest common factor is the greatest factor that divides into each of them evenly. So the highest common factor of 2 or more terms, because we can have more than 2, the highest common factor is going to be the greatest factor that divides into them evenly. And we know now that a factor could be a number, it could be a term, and it could indeed even be an expression. Now what we're going to be focusing on here is really the first two. We're going to be looking at numbers and we're going to be looking at terms. And included in terms, I suppose, we're including that idea of a variable, a letter. So we're looking at the letters as well. So let's look at these examples really quickly. So we have 4x and 16x first of all. So if I just focus on the numbers, what number divides in evenly into 4 and also 16? Well, we should know that the number that would divide in evenly would be 4. If I look then at the letters, I can see that 4x, I know that can be divided by x because 4x divided by x just gives me 4. So I know 4x can be divided by x. I can say the same for 16x, which means that the highest common factor overall is 4x. If we apply the same thing for the next one, then the biggest number that divides into 2x and 4xy is 2, and the letter that divides into both of those there is x. Okay, y would divide into the 4xy, but not the 2x. So we can't include y there. Looking then at 3x squared and 9x, the biggest number that divides into both of them is 3. And looking at the letters that I have, we know that x squared can be divided by x, and we know that 9x can be divided by x. So the highest power of x that I can include is x there. It's just x to the power of 1. And we can make a little note that that is the smallest power of x. So for situations like that where we maybe have x squared, the biggest power of x we could take would just be x to the power of 1. Because we can have 3x squared divided by x, and that would give me 3x. And I can have 9x divided by x to give me 9. But I can't do 9x divided by x squared, because that won't work. I can't divide x by x squared, because it would leave me with an x. It won't divide in evenly. So this comes back to that idea of it having to always divide in evenly in all cases. So when we're looking to factorize now, we've been looking there at what the highest common factor is, but now for factorizing, as we said at the start, that's going to be writing it in terms of as a product of its factors. So the steps in doing that then, the first step is what we've been doing there. Find the highest common factor of each term in the expression. So we look for the greatest factor, the largest number and letter that would divide into everything in the expression. It has to divide in evenly to all terms. We then write this highest common factor outside the bracket, and we divide each term by our highest common factor. And then the last little step is just to check our answer by expanding our brackets. So let's apply that now to these 3 examples here. So we start off with 9x squared minus 63x. So the largest number that would divide into both of those, the largest number that divides into 9 and 63 would be 9. Okay, then in terms of the x values or the variables that I can take, the highest power I can go to there is just x, because x squared can be divided by x and x can obviously be divided by x. We're thinking about what can I take out here, what can I factor out? Now we've followed our first step, we find the highest common factor, we've written that outside a bracket. Now what I need to do is I need to divide each term by my highest common factor. So looking at those individually, 9x squared divided by my highest common factor, which is 9x. So 9x squared divided by 9x just gives me an answer of x, because 9 divided by 9 is 1, and x squared divided by x, which we said at the start, just gives me a value of x. So what's going to be left in here is just x. Looking then at the second part, I have minus 63x, so let's take that out to the side here. Minus 63x divided by 9x. So minus 63 divided by 9 is going to give me minus 7 or a negative 7, and the x value will go away because x divided by x just eliminates the x there. It divides into 1. So I'm left with my bracket there as x minus 7. So we've successfully factorized this expression. So I've written it in terms of its factors. Now to check my answer, I can do that by multiplying across. So that gives me 9x by x plus 9x by minus 7, which gives me my 9x squared minus 63x as expected there. So we've successfully factorized that one. Let's do the same thing with the second example here. So again, I'm looking for the largest or greatest factor that divides into both of these. So we'll start with the numbers. So the biggest number that divides into both 36 and 48 is what we're looking for here. So the biggest number that would divide into 36 and 48. And in this case, that's going to be 12. Okay, that's going to be 12 because 12 goes into 36 3 times, 12 goes into 48 4 times. Now if we look at the letters, we can see I have an x squared here and I have an x, so the highest power I can go to is an x. The same thing happens with the y's as well. So we have a kind of a larger factor here this time, 12xy. Now we just have to double check that we're happy that that does divide into both parts. So 36x squared y divided by my 12xy, my highest common factor. Well, we've said the numbers there, 36 divided by 12 gives me 3. The x squared divided by x gives me x. The y divided by y means that the y's are kind of done for. Okay, looking then at the green part here, minus 48 divided by 12 gives me minus 4. And it's important that you remember that sign there. Okay, important that you remember that sign. X divided by x just gets rid of the x's, and the y squared divided by y just gives me a y value there. So I end up then with 12xy multiplied by 3x minus 4y. Then to check our answer to make sure that we're right, we can multiply out, we get 36x squared y minus 48xy squared, as expected again there. So we're following our steps the whole way down here, divide each term by our highest common factor, writing our results outside our bracket, and it's just following these steps the whole time, okay, and making sure you're content that, for example there, that the biggest value of x that would go in would just be x to the power of 1. Okay, so in terms of those powers, it's the smallest power of x that they all have in common that we kind of look for in that case, I suppose. And in a way, if we want to just explain that a little bit further, maybe, which could be no harm at this point, is if we think about what x squared means. So remember, x squared is x multiplied by x. And x on its own, obviously, is just 1 power of x. So the factor that they have in common is just that 1 power of x, x to the power of 1. So in a similar way, if it was x cubed and x squared, I would have x times x over x times x, and what they would have in common this time would be those 2x, or x to the power x squared, x to the power of 2. So we're always kind of looking, it's going to be a lot of the time that smallest power of x that's in the question, but that's kind of where we're coming from with that one, a little bit more kind of elaborated upon, I suppose. So let's just look at this last example. So a little bit longer for us this time, a little bit more involved, but following the same idea here. So let's look at the numbers first of all. So the largest number that divides into each of those would be 9. In terms of the letters there, I can see I have an x squared here, but in the other two terms, I just have an x. So I can only divide by x there in all three terms. So I'm going to say x, and then I need to look at my other letter, and I can see that I can in fact divide across by an a as well, because they all have an a in each term, at least a minimum of a to the power of 1. Looking at the first term then, 9x squared a divided by my 9xa. So all that's going to remain is the x there coming from the x squared. Same thing with the second one then, I have plus 2a this time. Okay, so the x is there again dividing into kind of cancelling each other out in a way. Then 18 divided by 9 giving me 2, and a squared divided by a just leaves me with a. Then for the last part, remembering my negative sign, minus 3, and the xa just removes then the two letters there. Then to check our answer, we just multiply that out with our kind of claw method, I suppose. 9x squared a plus 18xa squared minus 27xa. So this is our general process that we're following, okay? And we would have done last year kind of laying out our factors, kind of matching them up and things like that. And I suppose with our algebra, it's getting into some sort of fluency to it is the important thing here. So it really does take practice. I've put in a good few questions for you to practice through here. Obviously, just do as many of them as you think you need, obviously. But there's plenty of questions there to keep you going, particularly working with those factors of x. So making sure that you're happy that, for example, if we go to one of these later examples here just to have a look. That, say for this example here, the highest factor we could get that they all have in common would be 5 in terms of our numbers, and x squared in terms of our variables there, because they all have at least x to the power of 2. So we're looking nearly for that minimum power that they have in terms of the variables there. But highest common factor, good one to practice, and you need to make sure you're happy with this one before you look at grouping then, because that's what we're going to do in the next video, but we need to have our highest common factor to be able to do that.